Hey, Dee Davis here with what every project manager needs to know about welding. In this topic, we're going to be discussing pipe welding specifically, metallic pipe welding. You can weld other kinds of pipe, but we're going to be talking about the metallics. So why is it important to understand metallic pipe welding for your project as a project manager? Because the more welded pipe there is on your project, the more potential risk you have to budget and schedule. Now, this does not mean that pipe welding is bad. That is not what I'm saying. Pipe welding is good. In fact, it's absolutely necessary for much of the systems on your project. Whether it's hydronic systems like heating hot water and chilled water, or it could be specialty systems like steam or process piping. Understanding the experience of the team that's going to be welding your pipe is really important. Experience matters. It matters a lot. I have had people tell me I can teach somebody how to weld and they can be on your site in 2 weeks. No, that is not what you want as a project manager. You don't want somebody who learned how to weld last week on your project this week because their weld productivity is going to be very, very low. Not to mention the quality of their welds may be struggling, and that's not an expense you need on your project. Just like real estate, it's all about location, location, location. Where the welds are taking place can matter tremendously with your weld productivity. Are the welds taking place in your fabrication shop? Are they taking place out in the field on the ground? Or out in the field up in the air at height? Are they taking place underground in a tunnel or in an underground location where you're in an open pit? All of these things can impact your weld production significantly. The weld production you get in the shop is not at all the same kind of weld production that you're going to get in a trench in the field. Size matters. How big is the pipe that you're welding? 2-inch pipe is a completely different scenario than 10-inch pipe. And once you get over 12-inch, it's radically different. When you have really large pipe, you might have to have something that's called brother-in-law welding. What that means is you have 2 welders on the same weld at the same time. That way you have continuous heat that prevents the metal from cooling and distorting your pipe. What kind of weld it is also matters. So how many passes you have to go around the pipe? It's more than one. Is it 3, 4, 6? It depends on the service of the pipe, how thick the pipe wall is, and what kind of pressures and temperatures are running through the pipe. If you have a high criticality pipe with a big wall thickness on it, you're going to have to spend a lot more time welding that pipe. More passes means more time and more weld inches, which makes a huge difference on your project budget and schedule. One of the most common types of welding that you're going to encounter is called stick welding. Now, stick welding is very, very common and we see it all the time. However, the quality of the weld can vary greatly depending on the experience of the welder. Somebody that learned to weld last week or last month is not going to be as fast, and the quality of their welds is not going to be as good as somebody who's been welding for years. This is where it really matters to get the really good experienced welders as much as possible on your project. TIG welding stands for tungsten inert gas. We find this in high criticality systems all the time. The blend of gases is very critical here, and this is where the welder's experience comes into play. MIG welding is a common welding type that you will find across the industry. It's a metal wire feed welding, and this requires a bit less skill than some of the other types of welding, like hand welding. It's important to know the difference between pipe and tube. Tubing is much thinner walled than pipe, and certain types of welding will not work on tube that can be done on pipe. Schedule 40 and Schedule 80 pipe are probably the most common thicknesses of pipe that you're going to see on a standard commercial or industrial project. You can also see Schedule 10 pipe. The higher the number, the thicker the wall. Schedule 10 pipe is thinner pipe than Schedule 40, and Schedule 40 pipe is thinner than Schedule 80. As you think about welding with all these different kinds of pipe, the thicker the wall, the more weld passes are required in order to seal that pipe up and make that joint. So the longer it will take. On the surface of it, it seems like all we're doing is putting 2 pipes together when we're welding, but there's a lot more to it than that. there are passes, and depending on the type of pipe, the type of service, the pressure, the temperature, there may be more passes required on high critical, high pressure, high temperature systems. So it's important to understand that there is a big difference between a welded pipe for, say, chilled water and a welded pipe for high temperature, high pressure system. Position of the welder and the material matters a lot. If they have to get into awkward positions, they're up over their head, working in a dark area, sometimes they have to perform a weld on the side of the pipe they can't even access, in which case they have to use welding mirrors. So think of like a dental mirror, maybe a little bit bigger than that they have to use. So now you've got to hold a mirror to see a side of a pipe that you can't even see with your eyes, and you have to weld that. That's a tough weld. That's called a position weld. So these positions that welders have to get in, especially in the field where they're making final welds and they're joining systems that have already been fabricated, can make a huge difference in your weld productivity. Gas purity and flow can make all the difference between an accepted and a rejected weld, especially if you're dealing in high purity. The speed in which a welder moves, whether they're doing it manually or they're doing an automatic weld with a machine, matters. If you go too fast, you'll have an incomplete weld. If you go too slow, you'll have pooling, which will cause problems as well. Believe it or not, if you're doing welding, electricity matters, and so do electrical fields. You can't weld properly unless you have a constant stream of clean electricity. Sometimes off of spider boxes and things like that, it can be problematic if we're using temporary power. The other thing that can cause problems is if you are doing layout with a laser transit nearby, it creates an electromagnetic field that can interrupt the welding machines. Material impurities can impact weld quality. Things like dirt, oil, grease, and grime, improperly stored materials can affect your weld quality. So you want to make sure that all materials are stored properly. So what do you need to look for when you're reviewing welders? Well, you need to look for a welding certification. Now, most companies have their own internal weld certifier. They have a person who's a quality control person who it's their job to make sure that they are getting qualified welders. They perform a welding test and they sign off on a certification document that says that this person can perform the following kinds of welds. And you need to make sure that the welding types and materials are the same that you need for your project. Check the dates of the welding certifications because they do expire. Every 6 months, they're required to have what's called a continuity certificate, which means if the person is continuously welding, the certifier will issue a continuity certificate vouching basically that the person has been continuously performing this type of weld for the last 6 months. If you have a certification that is years old, and this has happened to me, ask for those continuity certs or a recertification of that welder. So how long does it take to become a really good welder? Well, it's a little bit art and a little bit science and a lot of practice. It can take anywhere from a year to 10 years to become really, really good at your craft. It's important that you're continuously producing the same kinds of welds to get really good at it. There's so many different materials. We have exotic metals that have to require different procedures. If you're doing the same kinds of welds over and over, you get really good at it if you're doing it all the time. If you do it once in a while, it might take you years and years to get there. So as a project manager, when you are being proposed all these different welders, ask a few questions. There's no harm in that. So we talked about all the different places that welds can be performed. So what's the fastest and what's the slowest? Fab shops are always going to be your faster welds. It's a clean, controlled environment where they've got everything set up and it is going to go the fastest. Now, the temptation is to say, well, we're going to do 100% of our welds in the shop. That's not possible. You're going to have to assemble the pieces in the field eventually, kind of like Tinker Toys. Usually about 20, maybe 40-foot section is about the biggest that you're ever going to get out of a fab shop. So you have to assemble that stuff in the field. I would say that percentage-wise, when you're looking at your whole project, you're going to have maybe 40 to 60% of total welds made in your fab shop. I have not seen it possible to do more than that. Your worst scenarios in the field are going to be working at elevation, like off of a man lift, over your head, or working underground in a trench or in a pit underground. Those require position welds. That's where you get into all of needing mirrors and being in awkward positions trying to complete your welds. Those welds are going to take longer, and the bigger the pipe, the thicker the pipe, the longer those welds are going to take. So what do you do as a project manager to try to manage all of this? Well, the first thing you do is make sure that you're getting as much done in a fab shop as possible. Encourage your owners, your contractors to utilize the fab shop as much as possible. The second thing that you can do is make sure that you are dealing with people that have a really good understanding of welding in the field. So I actually had this happen to me on a job one time where I had a foreman that I didn't realize knew nothing about welding. And I asked him to put together a schedule for me on what it was going to take to complete this underground work. And the schedule he came back with was radically off. Now, this wasn't this person's fault. They tried their best, but fortunately, I knew enough about welding to know that this schedule was not going to make it. Instead of the estimate of 10 days to do this welding, it was going to take 20 to 30 days to do this welding. You don't have to be a welding expert. You don't have to be a welder. You just have to know enough to ask some questions. And if you can, find somebody who knows a lot about this stuff and ask for a double check. Finally, ensure that your project budget and schedule is properly accounting for what it's really going to take to do this work, especially the field work. Having an unrealistic schedule or an unrealistic budget for the work doesn't help anyone. Thanks, and good luck out there.